Hi, hello everyone, and welcome to this video. And in this video we are going to work on point lights. But before that I want to showcase something. So this is where we left off last time. But what I want to showcase is we have a bug with our normals, and that's because we don't transform them. So I'm just going to showcase this issue. So I'm in a pedal right now, so we're just going to rotate that pedal. And I'm doing this because translate should be first operation. Then we have time equals scale, and here between those two we can add basically rotation, and that's going to be around z-axis. So I'm just going to pass some angle, and then we can define some angle private to our angle of type float. By default it's 0, and then we can just increase that angle plus equals 0.01 maybe. So hopefully it will rotate now. And it does, it's just behind. No, I made a mistake. This should be time equals. Okay, that's not a big issue. So let's see now. And here you can see that light, as this rotates, actually this is actually correct. So what I wanted to showcase, I'm thinking a bit ahead of myself. So I'm just going to redirect our light here to go towards maybe left. So it comes from the right towards the left. So we have to focus now on the left pedal. Okay, let's see. And as you can see, this side now is shadowed, but as it rotates, this side is lit, and that's because we're not transforming our normal for transformation and translation. So that's what we're going to do this time. Okay, so what do we have here? So let's say this is our normal vector for now. It's not unit vector, but it really doesn't matter for this example. So let's say that we have some object that goes from 1 to 1 in x and y. So this is a floor or something. We can ignore the z. Z is not important for this example. And so we have vector, which is this one, which goes towards 1 1, and this is orthogonal vector, right? So this will showcase the scaling issue. But what if we were to scale, let's say x by 2? So this now goes towards the 2, and this thing is not orthogonal anymore. So we have an issue here. So how can we solve it? Well, if you remember, and maybe I should change color to be, let's try with red. If you remember, our scale matrix, this is 2D scale matrix, is going to be x scale 0 and then 0 and then y scale. Well, we're just going to ignore z. So if we were to scale x by 2, so what does our matrix look like? So it's 2, it's 0 and 0, 1. We're not changing y scale. So this is our matrix. So how can we change that vector to basically be the same? So if we do scaling by this, our vector is actually going to be, so let's try to scale our vector. Let's do another one. So let's say 6G. As you can see, this is actually not orthogonal vector, right? It's not orthogonal to this basically line. But if we were to actually do inverse of it, so inverse, this basically gets divided by 2 instead of multiplied by 2. So we would have 1 divided by 2, or 0.5, and then have this. So let's try this example. So here we're actually going to have 1.5 because we were dividing, and now it should be orthogonal, and it is. So we kind of have to do the inverse, so my poor drawing, but it's actually orthogonal. So if we do an inverse of the scale matrix, we're going to cover non-uniform scale. So if you scale uniformly, let's say we scale by 2 by 2, right? So this one, excuse my drawing, but this one would be right. But if it's non-uniform, you have an issue. And same is for rotation. We have to undo our rotation, and we already discussed that with the view matrix. How do we do it? We do the transpose, right? In the transpose, so our rotation might look something like this around the z. So we might have some sine, cosine, cosine, sine. This might be minus, I don't even remember anymore. But if we would do the inverse, we just transpose it, and then this, so this might remain sine, this will remain sine, this will be 1, but this would be minus cosine, and then cosine 0, 0, right? Anyway, it's not important. So what's important is we know the math. We need to do transpose and inverse of the transform matrix, of the model matrix, and then we will correct our lights. So actually let's start with that. So right now I'm in unlit, in material shader. So just pop material shader in, and then we have here transform. So this is going to be similar. We're just going to call it normal matrix. And then we have to offset these positions. I just want to keep this organized a bit. And then here, since our matrix, for simplicity, we're going to keep it 4 by 4. You could paste 3 by 3. I'm just going to paste 4 by 4. So we're actually going to have cast then our normal to be vector 4. And then we can multiply our normal matrix. So it's similar to our transform. So we need this ID, right? Because we're going to paste instances. And then here we can just move all of these brackets and say x, y, z. And that's our normal now. So this is already going to work. We just need to define transform buffer and then paste the transform buffer in. So the transform buffer, right now I'm in pedal, so we're going to have to do the same for ball. It's going to be exactly similar to basically this one. Sorry, not the transform buffer, the inverse transpose of a normal matrix. So we can just call it normal matrix buffer. It's very similar. So here we can just initialize it. That's not too hard. And then we have to do the math here. So we can, after our transform, let's say in normal matrix. So we can define normal matrix. So what did I say? We can do inverse transpose of transform. And then we just have to write the normal matrix buffer. So our data is our normal matrix. It's complaining about something. It's called invert. Is it SIMD inverse? All right, and then this is probably SIMD transpose. Yes, it is. Okay, that's it. We're just going to need to paste it here. Then we're going to do similar stuff for our ball. We can just paste it right after the transform buffer. So I need to create it in our ball as well. And then we can just say is equal to this. Okay, that's it regarding this part. So now we just have to fix our material as well for those changes. Sorry, not material shader, our render pipeline. So here it's going to be very similar. We're just going to say normal matrix buffer. Here I mentioned that we changed all of this. So this is now 6. This is, so this one is 6, this one is 7. If you remember, we changed it in shader. So we're just going to do this, say 5 here, and then paste the normal matrix buffer in. All right, moment of truth. Does it work? it does not. Let's fix that quickly. So let's see. So this is getting lit as it rotates. Remember our light, right? Our light goes into this direction. So this is natural lit and is not hit by light anymore. Now it's hit by light, and as it rotates, it's gets black. So okay, that works. All right, that wasn't too hard. So now let's just focus on the point lights. So okay, the point lights. So they're very similar to directional light. Let's just open our material shader. Let's see what we did here. All right. So in our material shader, what did we have here? We had this dot, if you remember. So what was dot? We had this idea of a normal and then inverse direction of light, right? So this is direction of light. And then we were doing dot product of two of them, and that usually gave us some value between 0 and 1. There were cases where this could be below 0, if normal was pointing here or light was pointing here, but then we claimed it to be between 0 and 1, right? So the point light is going to be very similar. So for the point light, we're going to need some additional information. So what we're going to need. So first of all, the only difference is how we get that directional vector. So the point light is, let's say we have some light here, and the point light basically has light that goes in all directions. And then we have some cube, right? And then we will have this idea of a fragment, right? And then between the light and a fragment, we can just subtract our light. So we can subtract our fragment position from our light, and we're going to get a vector that looks like this. Usually we're going to normalize it, and that's our light vector, which we're going to use for this, right? We have this normal, then this guy, right? This direction is actually this. All right, enough of drawing. So we can just create a point light here. And before we do that, we're going to need to pose that, get that fragment position. And what's the fragment position? Well, it's just our vertex times the transformation vertex. So that's the fragment position. That gives you fragment position. So we can just say here frag position, and then out at frag position. And you can probably optimize this a bit because I'm doing this now twice actually. So you can probably optimize on your side. I'm not going to because I don't want this video to be too long actually. Okay, and it needs to be vector 3, so we can just say .x, y, z. So that's our fragment position, and now we can create a struct for our point light. So we're going to have position, and then what we're going to have, actually, did I already create it? I did. All right, we have our point light, and since our point light, there can be multiple per scene. So we're actually going to learn how to pass them as an array. Since I'm passing them as an array, I want this to be, all of this to be packed into 8 bytes. So I'm just going to do this, float, and then do this. So it's not important float, but because I want my data to be packed in 8 bytes, I'm doing this, otherwise you might run into issues, as you know, usually memory alignment and stuff like that. So we're just going to pack that in, and then we're going to pass here an array of point light, and here just changes this to array, and here we can say point lights, and let's say that by default we're going to pass 3 of them. So what are we going to have? We need to have for loop, I is less than g I plus plus. Okay, we're getting there. So here it's complaining about something. This needs to be 3. Oh, okay. So let's see how are we going to do it. So first of all, we need direction. And as always, we're just going to normalize it first. So what did I say? We had this out fragment position, but we care about point lights, I, right? Dot position minus out frag position, no, sorry, in, right? No, but it's here. Oh, typo. My bad. It's just a typo. Okay, as you remember, I mentioned that light needs to be reversed. So basically, this is a direction of the light, but when we're doing the math, it needs to be reversed. So that's why actually we subtract from the point light position. Okay, and then this remains the same basically. So here we're going to have float g point amount, and it's a dot of, we already we're going to normalize in dot normal, and then we already have direction, we have that dot vector, so we can clamp it similar to here and then edit. So I'm just going to paste this very lazily. Light amount. I think we're good here, so this should be all right. Okay, next what we need to do is actually create a point light. So let's do just this here. So very similar to directional light. So I'm just going to lazily copy paste this. There is going to be one small difference because it's an array. I'm going to have just an additional object here, which I'm going to call. So let's first do point light, and then we're going to copy all of this, and then I'm going to say here class point lights collection. Oh, wrong. Okay, let's see, what do we have to change here? So we're going to have an array of point lights. Oh, I can just call it lights. So it's an array of point light. Let's just initialize it. I can say here point light. We have to do it 3 times, right? So I'm not going to do additional checks if this array has this length, if this array has this length. It just takes time, so I'm just going to keep it short. So we have that. We need to write to it. So we can write with a loop. So let's say for I in 0 to less than 2. So what do we want to do? We want to do all of this actually. I'll write data, but here let's say just our light is point lights actually I. So here we're passing light dot color, light dot color. This is fine, intensity, and here it's not going to be direction. I'm just going to fill it in a second. So it's going to be position. Right, data, and then here we're just going to pass I. What was it called? Instance. I don't remember the overload. Let's quickly check it, because I know that we can pass an array or you can pass an array or say instance actually, and then the count. Okay, let's do that. Let's just say an instance, because we're already in a loop. So I can say instance here and then pass I. complaining about something. Let's see. Okay, apparently you cannot have spaces here. And then light. Aha, I didn't rename this to position. Now it's alright. Alright, that should cover our point lights collection array. We have a buffer, we just have to pass it now to our render pipeline. And we can pass it here, point lights. We can pass that collection in. Then index 3. There is a lot of coding here for really simple math. That's the drawback of lower level APIs, I guess. Alright, and now we have to create those point lights. So here and here we have lights, so our point lights is point lights collection device repeat point lights dot 0. So we can set position to some float 3. What do we want? We want to for it to be in front of our object, so we can pass this randomly and then just set our z to -1. And then dot lights dot color. So here you can just pass whatever, let's say 110. And then we're going to do the same for the second and the third one. 1, 2, 2. So here let's just say maybe 6 and 1. It doesn't matter. So here I'm just going to play with the colors. And here I'm going to say 1. And maybe here 1 and here. And for the colors to look correctly because of the multiplication, right? If you remember, we just set our pedals to be blue and green fully, but you can do a bit of this, right? Pass 0.3 here, 0.3 here, and 0.3 here. So just so that channels that are 0 receive some light as well. So you can do that for both of the pedals. For the ball, it doesn't even matter, it's fully white. Alright, so last thing that we have to do is finally, in our pedal, we just have to pass those lights in, exactly. Okay, let's do that. Here, point lights collection. And then here we're just going to say point lights. Almost there, hang on. Then we have to do it here as well. And then here as well. And if everything is passed in correctly, it should work. But it's not, because I forgot it here. So all right, as you can see, it kind of works because the colors are all mixed now, and that's because of the point lights. So one thing that we can do to show them more clearly and their position is actually to create a kind of background that's going to react to light as well. So let's just do that quickly. So for this background, it's actually just going to be some floor object. So let's say here floor. It's weird though. Did I update the lights? The update should be called, yet they react to light. I think I did something wrong. Let's just check quickly again. I think I didn't do this right, so it should be different colors a bit. So let's see. It reacts to light, but it's still difficult to say if our lights are set correctly. So let's actually do the floor, because then it's going to be clear. Okay, so we can copy ball or the other one. So I'm just going to do this. Copy floor. Scale, we're going to change it, so you can just say X and Y, like some big value like 40. Position, we just want to be at -1, so in front of everything, and that's everything that we need to do. We can go back to our coordinator. We can say here our floor, so type floor is nil. Then we're just going to initialize that floor. Do we need to update it? No, we can just draw it. Let's do this, and let's say floor. And the thing with the floor is we just want to have some dark color actually, so that we see how it reacts to lights. So we can just paste in 0.2, 0.2, 0.2 for color. And if now everything is correct, we should be able to see some lights. It's in front of everything. My bad. Should be not -1, it should be 1. It should be behind everything. Let's try again. Open anyway. Okay, here are the lights. Also the color of the lights doesn't seem to be correct. Let's check that. So first of all, what I want to do with the lights, I want to wrap up this intensity to 1. And the color should be actually alright. Now maybe it's just intensity. That was kinda low. No. So how can we debug this actually? So what I'm going to do is I'm just going to expand our buffer a bit. So here I have added label, and then I have paste buffer label in. So this will be useful. You're going to see why, because now for the point lights, we can say when we're creating this buffer, we can say label. How can I say label? So I just realized my mistake. First of all, look at this buffer. We're writing 3 times to it, but we don't have enough space, right? We never said, we never passed in the amount of space that it needs. So we wanna do memory layout of simd. So we're writing to this object, right? We want size and then ×3. So we need to allocate enough size, and then for the label, we can just say point lights buffer. So I'm just going to start to run it, but let's try. Maybe that was the issue, not enough space. No, it's not, but I did this on purpose because we can now capture the metal frame stack, and I'm not sure why this is happening. So I cannot capture the frame. Alright, I was actually able to catch it. So you have this small metal button that you can use to capture the frame, which is somewhere over here. But let's just check all resources, and then I did this label so that I could see point lights buffer here. So it's probably a good idea to use these labels. I didn't use them, and that's shame on me. But let's just check the contents of our buffer. So we have float 110, that's the color of the light. Then this is intensity, that's quite alright as well. And then we have position, which is correct for this. It's correct for this one, but the last one is not correct. So let's try to correct that. So it might be issue here. So let's just include this as well. I hope that's it. Let's just try to run it. Okay, I still have nothing, but I'm going to actually move this a bit. Let's say 7. The second one -7, and the third one can be somewhere around the center and bit up. So let's see just if our positions are now correct. Ah, you know what I forgot to do? Oh, wow. So let's just go to our material shade, and now I remembered. So we did all this math, point amount, but did we ever multiply it with color? No, we did not. So that's probably the reason why it's not working. So we have to do color and then point lights times intensity. I totally forgot to do that, and that's probably the reason why it's not working. So now, okay, we can see our lights. They're here, they're working. So next time we're actually going to play with the attenuation of the lights, which is kind of fall off from the lights, because we don't want these lights to go indefinitely, right? The further they are, we want to have actually lower range. So we're going to play with that next time, and also we're going to create some objects that can represent these lights, so that we don't have like to do this floor and stuff like that. So that's it for this video. If you enjoyed it, please like, subscribe, and until next time.